So we're going to try graphing a quadratic again. So a great place to start is always with your vertex, negative b over 2a. So this time I'm going to have negative 10 over 2. So my vertex is at negative 5 comma something. Everybody agree? So plug negative 5 back in and see if you can figure out where. Don't say it out loud, just get your answer. One is correct. Did everybody get one? Okay, perfect. So now I know my vertex is at negative 5, 1. I also know a whole bunch of other things. I know the equation of axis of symmetry would be what?
X equals negative 5.
X equals negative 5. I also know that this graph is up like a cup or down like a frown? Up. So therefore, I actually also know my x-intercepts. There are none. So how am I going to graph the rest of this? Well, you could plug in points and find the other pieces, but when A is 1, there's a very convenient pattern that you can follow. Do you know it? Kind of for your first point. So we have an axis of symmetry that goes right through the vertex. If A is 1, yeah, to get your second point, you just go up 1 over 1. And don't forget, it's buy one, get one free. So whatever point I have here, I get to mirror over to the other side. So whenever A is 1, there's a pattern to get from one spot to the next one. So starting at your vertex, you go up 1 over 1. To get to the next point, it's up 3 over 1. And if you had to keep going, it'd be up 5 over 1. So you're going up the odds. So from here, I can just go up 3, 1, 2, 3 over 1. You don't have to take my word for it, though. You can actually plug it in, right? So according to my graph, negative 3 should come out to be a positive 5. If you take negative 3 and actually plug it in, you should come out with a positive 5. So let's just see. 9 minus 30 plus 26. Is that really a positive 5? It is. Wow, how about that? So when A is 1, you can just follow the pattern. Up 1, up 3, up 5. And then I can just connect with a nice smooth curve. Does that make sense? Tell me what you know about number 3 before we even start. It's up like a cup. What else do you know about it? It's going to be wide. Yeah, these are when A was 1, right? So that's just my normal U shape. This is going to be much wider than that. So if there was multiple choice, right, I'd be looking for a wide graph that's up like a cup. If it's not those things, I could cross them off. But let's go ahead and try and graph this thing. Where would I start? Negative b over 2a, which in this case would be, yeah, just 0 because my my b term is 0. So it'd be 0, comma, yeah. So in that 1, I get my vertex. I also get my y-intercept. Okay, so let's see. What else could we do? We can try and find the x-intercepts. I actually think that they're going to be a little big, though. Like, I think they're going to be off our grid. But we can try and find them. If I asked you what the x-intercepts were, how would you find them? Yeah, replace y with 0, and then I'd solve that by square rooting, because I don't have a b term. So I'd have 0 equals 1/4 x squared minus 5. Add the 5 to the other side. Then what would you do? Yeah, multiply both sides by 4. And then... oh, that'll fit on our graph. What am I saying? Never mind. In my head, I had it as a much bigger number. Yeah, because now all I have to do is take the square root of each side. That splits into 2√5, positive or negative. So I'm just going to ask my calculator for a decimal approximation of what 2√5 is. And it's about 4.5, a shade smaller than that. So
What is it about?
4.5. So a positive and a negative. Oh. So you could connect these. I say you should at least have 5 points though. So this is only 3. So if I just plug in one more, I can just mirror it over using the axis of symmetry. So, I don't know. I'm going to plug in a smart number. What would a smart number be to plug in?
16.
4's not bad. I wouldn't do it because I already have a point so close to 4.
Okay,
I might do 2. Because if you do 2 squared, I can multiply by a fourth nicely. So 2 squared is 4 times a fourth is 1. 1 minus 5 is? -4. So 2, -4 is a point on my graph. Buy 1, get 1 free. So there is the shapings of our parabola. So that should be enough to connect with a nice smooth curve. And you can see that this one is certainly wider than the 2 previous ones that we've done. Which makes sense because A is smaller. Tell me what you know about number 4 before we even start.
down.
It's down, and
It's
it's going to be more narrow than these graphs for 1 and 2 were. Not a lot, because 2 is not that much bigger than 1, but if you put them one on top of another, you would certainly see that this would be more narrow than that one. All right, so find the vertex. Don't look up at my paper until you've found the vertex yourself. Are we all in agreement? What's the equation of your axis of symmetry?
X equals 1.
X equals 1, so there is your axis of symmetry. Okay. I could also ask you about the X-intercepts right now. You know them without doing anything else. What are the X-intercepts this time? There aren't any again. This one's going to be down, right? So this is the highest my graph will ever get. I'll never cross the x-axis. They're going to go down. All right. So how about we find our y-intercept? That'll get me that point and another one on the other side. -5. Plug in 0 for x, I get out -5. Buy 1, get 1 free. I should plug in one more point. I'm just going to have to plug it in directly. Yeah, you get to choose. You can either plug in 3 or -1 because you're going to get the same answer for them. So it's up to you which one you plug in. I don't care. Just make sure you got it down pat. Did you get -11? So that's a bit off my grid, but it's in line with what I would expect. So if you take a look at your graph in number 4 and number 2, you can definitely tell that 4 is more narrow. So what do we think? Easy enough? Graph these things in standard form? Can do it all day long? It gets annoying when your vertex is not on a nice point. Then you're just dealing with fractions and decimals, but whatever. It's not anything you can't do, it's just more annoying. Dare we try number 11? No. Well, I mean, you could clear them when you're solving the quadratic. You could do that. But, like, when I go to find the vertex, I'm going to need that there. I'm going to need all the pieces as they are. Oh, let's give it the old Tantasquin try. So, let's try with that vertex. -b over 2a. How do you divide a fraction with a fraction? Wow, thanks. Okay, I got them for Tyler H, Tyler F. Oh, Julia's not here. Oh well. Tyler's. You got these thingies. Oh, you heard me. Okay, good. Oh, Julia's not here.
Oh, okay, thank you. Here you go.
I got one more. Liberty. Thanks. Okay, ready for 11? This might be a bonus problem, maybe. I don't know. Tell me stuff you know about it already, though. It's up like a cup. It's going to be wide. That's a good start. All right, so it's up and it's wide. Let's try -b over 2a. Oh, yeah, I was asking you how to do a fraction divided by a fraction. Because I'm going to have -2/3 divided by 2 times a would be 2. Oh. That's not even an exciting fraction. What's -2/3 divided by 2/3? Just -1. If they were different fractions, though, what would you normally do? Keep change flip. That's it. So I just get -1 comma something. So let's plug in a -1. So that would be 1/3 minus 2/3 minus 14/3. At least they gave us all common denominators. That's pretty good. So let's see, what's that? -1, -15/3. Huh?
No. Because wouldn't it be -13/3?
Nope. 1 minus 2 is -1, right? -1 minus 14 is -15/3. Just -5. No, you're right with the negative. Just -5. Oh, this isn't so bad at all. -1, -5. There you are. There's my vertex. So now I could answer axis of symmetry. I could tell you if my vertex is a max or a min. Which is it? A min, right, because it's going to be up. I could... Well, you can very easily find me the y-intercept. What would that be? -14/3, which is -4 2/3. So just about there. Beep. Buy one, get one free. Here, maybe it would be helpful to find the x-intercepts. I think so. So if I want to find the x-intercepts, here I can clear the fractions. So I can replace y with a 0. So I'll just write it out. So you have 1/3 x squared plus 2/3 x minus 14/3. But now, can't I multiply everything by 3? Yeah, so now I'm just going to have 0 equals x squared plus 2x minus 14. And now my life gets really easy because what can I do with that? Yeah, I can factor that to be x plus 7x. Oh, shoot. No, I can't. I had 2 in my head thinking 2 and 7, but okay, never mind. I can't factor that. Yeah, if we can complete the square, that wouldn't be so bad because a is 1, b is even. So let's add 14 to the other side. X squared plus 2x, leave a space. We'll have a positive 14 on the other side. Half of 2 squared is 1, so we'll add 1 to both sides. X plus 1 squared equals 15, square root. So I get -1 plus minus square root 15. Now, how does that help me on a graph? You got to turn that into a decimal. So if I figure out what the square root of 15 is, 3.87. So I'll do -1 plus 3.87. So one of my intercepts, x-intercepts, is at 2.87. And then I'll do -1 minus 3.87. Duh. I didn't even. Sometimes I'm like, do you even teach math? Look at what I literally just used the calculator to do. Like, I couldn't do that in my head. I tell you. Oh my gosh. How embarrassing. Oh. Alright, there they go. Oh. Now I have enough to make a nice smooth curve. I gotta remember to edit that out of the video. One day someone's gonna listen to these and be like, wow, this lady. Okay, what do you think? That one wasn't as bad as you thought it was it? No. Especially because the vertex came out really nicely. Alright. Any questions on these? No? You feel good? Do you remember doing this? No. Okay, that's alright. If you haven't, now you know.